whatever you've got at me. There's nothing I can't handle.
Fantastic. Again, welcome to the Tech Equipment live stream Q&A session. My name's Dion Knowles. I'm joined by Dave Giddings. We are working from our home offices and we are streaming live on YouTube. If you're watching this on demand, then we hope you enjoy it and post your comments in the comment box below. If you are watching this live, then please do put your comments in the chat box. So I'm just going to put that over here.
So if you are watching this on demand, this coffee now will be cold, okay?
Right, okay. How's your afternoon been, Dave? I know we just come out this other call, but
it's okay. You know, we've done some emails, we've had some customer care emails, we had some sales related emails. We're keeping things ticking over. We're making sure that people know that we're still here, be it in far-flung corners of Nottinghamshire and Derbyshire. Yeah.
Good. So I'm just syncing all of my YouTube screens out. I've got you on my, you can't even see it because of the green screen thing. There we go.
I can now. I can see it.
Yeah. So I've got it. I've got it on my screen on my phone. I've got it on the screen over here. I can see what everybody's going to see. Right. So I'm going to start with a question. This first question, Dave, is about the TD200 engine test set. Let me pull that up on the screen so everybody knows what we're talking about.
Yeah.
Small engine test set.
Yeah.
Now, it's got detachable engines, hasn't it?
Absolutely. Yeah.
What's put that on there. How difficult is it to change these engines? Because it's not a small piece. Yeah, is it difficult? Easy?
No, you need a help of an assistant. Okay, the engines are heavy. The diesel engine is heavier than the gasoline engine. To change an engine, so you'd want to kill the power, switch off the power supply to the control panel, turn off the water supply to the TD200 bed. It's a water dynamometer, so we don't want water being consumed for nothing, for no reason. Remove the red guard. You might just be able to see that on the picture that's just flagged up. There's a red guard that covers the coupler, so the engine needs to be coupled to the dynamometer, and underneath there is that coupler, so we guard it for obvious reasons. So remove the red guard with 4 6mm caphead screws. Then we need to disconnect the fuel line because you're putting on another engine, so you might be swapping from gasoline to diesel or vice versa. Undo the exhaust thermocouple cable, so that's just an 11mm AF spanner. Remove the thermocouple. If you don't remove these, then you'll end up causing damage because you'll be walking away with an engine still connected to the control panel. So that would mean customer care gets a phone call or an email. Okay.
Right.
Then you'll need 4. You need to undo 4 of the main bolts that hold the engine to the bed. So you get some spanners. There'll be 19mm spanners because they're 12mm bolts. Undo those 4 bolts, put them to one side. Then, with the help of a trusty assistant, you lift the engine away from the bed, place it on the table, on the bench, lift the other engine up. Don't drop it onto the bed, but place it onto the TD200 bed. Line up the 2 pins, or the dowels as we call them. When they're lined up, you know you're quite close. And then you just wiggle and jiggle the engine so it mates with the other coupler. And because it's rubber, there's a bit of flexibility. So that's why you need to do that just for the engine, just to tee it up. When it's lined up, then you're good to go. You need to tighten up the 4 M12 bolts, reconnect your new fuel line, because you can't use the existing one because it'll have the old type of fuel in it. You'll change the fuel tank because it's using a different fuel. Reconnect the exhaust that you've already disconnected. and reconnect the exhaust thermocouple that is screwed into the cylinder head on the engine. And then you're good to go. Switch on your water, switch on your power, make sure you've got fuel flowing down to the injectors if it's diesel, or the carburetor if it's gasoline. You notice I'm going very American at the moment. I'm going from petrol to gasoline, so I'm tending for everyone that is minus British summertime. Okay, so we're talking about gasoline, not petrol. Same thing. And then you're good to go, Dion. You can do your engine tests. So the whole procedure takes between 10 and 15 minutes.
Oh, as quick as that. Wow.
Once you've done it a few times, you can do it quicker. And I can do it on my own because I know, I've been doing this for 12 years. It's not a difficult process. You just need to concentrate on all the steps, make sure everything's connected and done up tightly.
Okay, good. Well, I just want to say to those people who've joined us live, I can see we've got quite a few people there. It would be great if you want to say hi, even put what country you're from. We've just been on Instagram. We were joined by people from Saudi Arabia, Bolivia, Turkey, India, USA. Where's Leandro from? Can you remember, Dave?
Leandro was from Nova Didactic in the country of Brazil, spelled with an S. With an S.
Not a Z.
Yeah.
Okay. Yes. So do put your comments, say hi in the comment box. Also, this is what we're here for. Put your questions to Digital Dave in the comment box below, and he will share his wisdom with you on the world and the world of tech equipment in particular.
Yeah. So would this be a good opportunity to answer some questions that came in after this morning's YouTube event?
Yeah, I tell you what, I've got some questions that came in on the YouTube comments about, not about that. This was in particular about the torsion testing machine.
Now this is live, unrehearsed. Hit me.
Right. So I'm going to pull up the video for people who want to see it quickly. YouTube.
This is the SM1001, correct?
No, I'll have to. I'm not so good at product codes. I teach myself not to think product code wise.
It is.
I think product name wise. I'm going to show you the product as I whiz through this one here.
Yeah, the benchtop.
Now this particular question here is, which meter reads the strain values of the gauges? I might be able to zoom in and find some nice closer stuff.
Okay, this is the first time I've heard this question, and I sound like a politician. I'm glad you asked that question. It's one I've been to answer for a long time. No, seriously, this is not a short answer. Okay. So with the SM1001, which is a torsion testing machine, Dion.
Yeah.
Okay. Just for your product code knowledge.
Thank you. SM1001.
It has 2 meters. We have a DL1, which is a digital load meter. Okay. And we have a DA1, that's digital angle meter. So let's start with the digital load meter. This doesn't actually measure strain. Okay, it is actually measuring torque. Okay, so we know the force that's being generated, or that the PCB receives a force reading from a load cell. Okay, and we then know the length of the torque arm. So the torque is a product of the force multiplied by the torque arm length, and that gives us the torque in Newton meters. So that's what the DL1 is measuring. We're measuring a torque. Now the digital angle meter, well, that's just measuring the angle of twist in degrees. Okay, so we've got 2 parameters there that will form a basic graph of load in Newton meters over angular deflection in degrees. Okay. Now going back to the original question, the stress and strains can be calculated by use of an optional torsiometer, which is the SM1001A. Okay, now the SM1001A measures very small amounts of twist, and it measures on a mitutoyo gauge, and we set that gauge to work in inches, not millimeters, in inches. And the very good reason for that is 0.001 of an inch displayed on that mitutoyo gauge equals 0.001 of a radian. And that's why the correlation is so convenient for when you do your mathematics and your equations. If we use millimeters, it wouldn't match up with the direct reading of radians. Okay, so once we've got our torsiometer fitted, we can then do some quite simple maths. The first thing we can calculate, or we need to calculate, is the polar moment of inertia. That's the J value. Okay, so that's pi, so 3.142, multiplied by the diameter to the power of 4 divided by 32. And that's our polar moment of inertia. With that, Dion, we can then calculate the stress. So you can see where this is going now. I'm going to tell you how we can calculate the stress and the strain. So to calculate the stress, it's the torque multiplied by the diameter of the bar divided by 2 times the polar moment of inertia. And that gives us the stress that is actually happening. This is experimental value, not theoretical. This is actually mathematics that you can do. Okay, so finally, going back to the original question 5 minutes ago, we can now calculate the strain. We know the strain because we take the readings in the radians from the torsiometer, and we introduce that into our formulas. And then if we know the stress and we know the strain, that will allow us to observe the Young's modulus on an Excel spreadsheet. Okay, now you can calculate the Young's modulus, but if you don't want to calculate it, you just look at the gradient in Excel. So dy dx, change in y, change in x, and that will give you the Young's modulus. But I must stress, the SM1001A can only be used in the elastic region. You do not proceed to the yield point into the plastic region. Otherwise, the specimen will break and your torsiometer will drop onto the bed of the SM1001. So it's purely an elastic region test. So you can calculate the stress, you can calculate the strain from the torsiometer, and then you've got a full set of results.
So no breaking things in this one. Absolutely no breaking.
I mean, I've done it accidentally. The chances are nothing will break, but it's still not good practice to drop a mitutoyo gauge, even just a few centimeters, because they're fragile.
Yeah.
Okay. So that's what the answer to that is. You have a DL1 measuring the torque in Newton meters, and you have a DA1 measuring the angle in degrees. Okay.
Okay, right. Now, I didn't find a bit on the video quite yet, which relates to this question. Do I have, this said person has said, do I have to add a guard or the guard to increase, i.e. add loads, the force gradually, or is it already on digital load meter?
Yeah, it's already on the digital load meter. Having the guard fitted is obviously recommended, because when the specimen breaks, you can get small splinters of surface material flying off. Okay, so you need to fit the guard. Okay, then you can observe by turning that hand wheel, and it's a 60-to-1 reduction. Okay, from the gearbox. Turn the handle, and you can observe the increase in the force and the twisting, the angular twist, both on those local meters. If you've got VDAS, this is a whole different matter. You can open up VDAS and you can do a timed recording where it captures every half a second, every 2 seconds. So you do not need to concentrate so much on stopping and starting, because it's always better to do a continuous test rather than stopping, waiting for the material to creep back a little bit. You'll get much better and a better quality graph by doing a continuous turn of that hand wheel, okay? And that's where VDAS is a big benefit, all right?
Brilliant. I do hope that has answered gentleman or lady's question. If it hasn't, then I do encourage you to come back next week or comment below to get further clarity and guide us where you want us to answer further. Good.
Yeah.
So let's go back now, Dave, to another question that I have here, which is about, let me just get rid of that, because we've seen plenty of me illustrating the torsion thing. And now we're going to talk about wind tunnels and models, 3D models.
Okay, yeah. Well,
we do them, don't we? Can you tell us more about those?
Yeah, we do. We certainly do. The 3D models that fit into our subsonic wind tunnels come in various shapes, profiles, and sizes. They include a teardrop shape, a sphere, a hemisphere, a flat plate, a golf ball or dimple ball, and a dummy stem as well, because the last thing we want to know and to interfere with our results is the false readings from the stem. We're not interested in measuring the drag, for example, of the stem. So let's measure the drag of the stem itself, which is the top model that you can see on your screens there. Once we've got that value of the stem, we can take that, we can subtract that from the overall, let's say, drag reading of those models, and that leaves us with the true reading of the model itself and not the stem. So that's what that that piece of bar with the clamp is on your picture there. So yes, we do 3-dimensional models, which when we can look at wake traverse, so we can see what's happening downstream of the models, which is the wake. We can also look at the drag, which is resistance to the airflow. Not so much lift on these models. We're not really looking at lift. That would be more reserved for our aerofoils and our model planes and our boundary layer experiments themselves, okay? So basically, yeah, drag and wake traverse. Traverse means traveling from the top of the working section through the center line where the model naturally sits, and then to the base of the wind tunnel. So we're traversing and measuring the pressure as we traverse or as we move from top to bottom of the wind tunnel.
Wonderful. Okay. As ever, a marvelous answer from
a long answer,
Digital Dave.
A long answer for quite a short question, but you know.
Thorough is the response, I would call it, Dave.
Yeah, thorough.
Okay, next question now it's about the MFP 101, which is
centrifugal pump.
Centrifugal pump module. Right, so somebody is having problems reading the torque or the power on this particular piece of teaching apparatus. So why do you think that might be? Oops.
Well, there's the two possible causes of that spring to mind, and Andy and myself in customer care receive quite a few inquiries in a year about this. So on the MFP 101, we have a centrifugal pump on the left hand side, just behind Dion's body there. And that centrifugal pump needs to be primed. We need to introduce water into that pump before we start it to make it work. So my suggestion is you undo the top connector on the MFP centrifugal pump, pour water into the pump until it overflows. Then we know we've got rid of all the air, because these pumps don't like to start with air in them. Okay, so we fill that pump with water, screw back up the PVC nut on the top, and then you're good to go. But the other reason, and this is quite common, in fact I'm guilty of it myself, is the transit bracket that is protecting the load cell in shipping is often left on. Okay, now even in that footage there, you cannot actually see the transit bracket because it's towards the back panel of the MFP 101. So it's a red rectangular bracket about that long. It's just clamped by two small M4 cap edge screws. Once that's released, then the torque mechanism and the load cells are free to measure torque. They're not restricted. So then the torque and the power, I'm pretty certain, will be displayed thereafter, which they wouldn't be with that torque arm clamp fitted, because the torque, the load cell has nowhere to go because it's being restricted.
Right. Thank you, Dave. That was very good.
You're welcome.
Let's now perhaps what would some of the questions that we got on Instagram that I think would be worth sharing. We had something about the centrifugal pump again. Can you remember? Nope.
There was a question about some low readings earlier on the centrifugal pump, and I suggested that first of all the customer should check their water level in the reservoir, make sure it's at the recommended height, and then I would repeat what I said earlier about priming the pump, make sure there is no air in the system, make sure that all the pressure tappings on the digital pressure display are being bled. So there's a little pipe with a connector that we just plug in for a few seconds before each session. That removes the air from all the pipe work, or the network of pipes from the inlet to the delivery to the optional turbines. So getting air out of the system is super critical to the success of this experiment. Okay.
Right. Great. Good. Thanks for that, Dave. I do remind anybody, if they have any questions for us to put to Digital Dave, do answer them or do ask them quite quickly, because we will be wrapping this session up very soon. Dave, now it's Easter weekend coming up now. Are there any pieces of equipment from tech equipment that you think could be used to do fun experiments related to Easter? Or... I'm really putting you on the spot there.
Well, I mean, I hope there's no animal lovers out there, but you could put an Easter bunny in the wind tunnel and check the drag of its floppy ears.
Well, you look, I've got a giant Minnie Mouse here. We should try and put Minnie in the wind tunnel one day.
Yeah, but this has no correlation with Easter.
No Easter, really. No Easter connections. No. Sorry, so, gone off on a tangent.
You could put the Easter bunny in the wind tunnel. I can't really say anything else because I'll have the RSPCA on my back once lockdown has been lifted.
Could we test the strength of Easter eggs in the tensile universal testing machine?
Not in this household, because they wouldn't last long enough. We all know once you purchase an Easter egg off the shelf, it has a life of about 3 or 4 hours. It must be consumed within that time. So no, I'm afraid not.
I always feel like I have to do my children a service, because they clearly often need a lot of help, because there's eggs to be eaten, and I'm doing them a health favor that if I raid their stash when they're in bed and eat their chocolate. And I'm sure there's plenty of parents out there that feel the same. I'm hoping so, because I don't want to feel like a totally bad mother for doing that. But it's when they've got like 10 eggs, it just can't go on.
No, no, no. I can't think. Nothing springs to mind about the relevance there, Dion. I'm
Oh,
struggling.
whoa, boom. Did you get that? Spring.
Yeah. Of course I got it.
Nice one, Dave.
Now
Anyway.
we must hop along.
Yes, absolutely. We must hop along. It's nearly dinner time. Thank you, everybody. Thank you, Dave. Fourth session of the day for joining us live on YouTube. It's been another great session. To those people watching on demand, we hope that you've enjoyed this, and those live as well. Do post your questions in the comment box below. And join us again next Wednesday. We will be back with more live Q&A.
I look forward to it.
Thank you and goodbye.
Thanks then. Bye for now.